to the Invest NS Tutor. We look at foundation mathematics question on radical equations. Solve the equation. Root of 2x plus 5 plus root of x minus 1 is equal to root of 3x plus 4. So to start with the first one, okay, before even solve this radical equation, step 1 is set the domain. All right. So for all radical functions, right, or equations, what is under the root should always be greater than or equal to 0. All right. So meaning our 2x plus 5 should be greater than or equal to 0. Our x minus 1 should be greater than or equal to 0. And our 3x plus 4 should be greater than or equal to 0. That is our domain. Okay. Now you know what you're looking for. Let's now start solving the equation. So what we can do is that since we have all of them under the root, you can just square both sides. Square both sides. So meaning I have a root of 2x plus 5. Okay. Sorry. Plus root of x minus 1. Then you square. Also square this side. Okay. Like that. So squaring both sides allows you to eliminate one of the roots. So if this side, the root, and when you square the root, you just get what is under that root. Meaning, if I have to expand this, what do you think I'm going to get? This part here. This part I know is 3x plus 4. But expanding this part means this times itself will give me what? 2x plus 5. Okay. Next, plus to be this, okay, times that. Isn't it? That's how we do it. But this will come twice because this is also going to multiply this. Meaning this will be 2 root of 2x plus 5. Okay. Remember these are roots, so the root is common, so I can just put them inside. Plus, now this is square to give me x minus 1. And this is equal to 3x plus 4. So I just repeated this twice. Meaning, remember, if I've got a plus b and a plus b, this a squared, and this is the this will be ab, another ab, so this will be 2ab plus b squared. This is what I have, 2ab, but the root is common. The root is common, so I just have to factorize the root in. Remember, if you have this root a times root b, just the same thing as root of a times b, because the root is common. And that's what I just did there. Okay, moving on. Okay. Now what we have here is very simple. All right, we can collect the like terms so that we can remain with, what do we remain with? Okay, so 2x and x, you get 3x. 5 and negative 1, you get positive 4. So be plus. Okay, or let me not use plus. This comes this side, becomes negative 3x. This comes this side, becomes negative 4. And this is equal to, I'll say, plus 2 root 2x plus 5 minus 1, and this is equal to 0. But this is 0, right? That is 0, meaning I'll remain with 2, in brackets, 2x plus 5, x minus 1, everything under the root, and this is equal to 0. So now what we do, again we square, or if you want, you can just divide by 2 throughout first. Dividing by 2 throughout gives us 2x plus 5 and x minus 1, everything under the root is equal to 0. Then we know, of course, we have to square both sides. Square both sides. And after squaring both sides, you just get 2x plus 5 multiplying x minus 1, and that is equal to 0. The only thing that now we are going to remain with is this part. We can't expand. This is just a normal quadratic equation, meaning 2x plus 5 is equal to 0, or x minus 1 is equal to 0. Meaning 2 meaning that x is equal to -5/2, or x is 1. Now, what you found here, all right, x is equal to 1 and x is -5/2. Which of the solution is valid? Do you know what we do? We go to our domain. The values of x must be greater than 0 or equal to 0. And the only number which is greater than or equal to 0 is x equal to 1, meaning the only solution for this type of equation is x equal to 1. Like that. Okay, with what we've done here, can you try this using the same concept?